Graphing functions by hand. Lines tend to be basic enough to either find the x and y intercepts and connect the points, or to find the y-intercept and the slope and then graphing. However, we're going to talk more about that later. Right now, we're going to talk about a different method of graphing functions. One quick way to graph any function by hand, if you don't quite understand what it looks like yet, is to use a table of points and then connect the points to see the trend of the graph. These are going to be some examples of graphing functions by hand, and we're going to be using tables. So in general, when we are doing this, if it is set up like this, where we have our x and our y on the same side of the equal sign, we can just find it where the x and the y are both equal to 0. So when the x is equal to 0, what is my y? When the y is equal to 0, what is my x? Okay, so that's how I'm going to do this one, and then I'm going to graph those 2 points and draw a line between the 2 points. So with the first one, if my x is 0, then I have 3 times 0 minus 5 times my y, which is equal to 15. Alright, so 3 times 0 is 0, so that's going to get rid of that, and then I'm just left with negative 5y equals 15. And now I solve as I always have before by dividing by a negative 5. So y is equal to 15 divided by negative 5, which is a negative 3. So the point 0, negative 3, 0, negative 3 is on this graph. So I'm going to graph that point. Now the other part, if I put in 0 for the y instead of for the x, so that would be 3 times my x minus 5 times 0, because we're putting 0 in for y, equals 15. So that negative 5 times 0 is going to cancel out to 0, leaving me with 3x equals 15. So what I have to do now is just divide by 3. So my x equals 15 divided by 3, which is 5. So my 2 points are going to be 0, negative 3, and 5, 0. Okay, so now because this is a line, I can draw a line between those 2 points, and that is my graph. So if it is a line, if you determine that the function is a line, just put 0 in for x, and 0 in for y, and then draw your line between the 2 points. So that's your method if it's a line. It'll just make it easier for you. Or you could graph a bunch of different points and then draw a line through all the points. It's the same idea. So in this next one, again, we should note that this is a line. It's a linear function, so because it's a linear function, we can pick 2 points. So I'm going to put 0 in for x, and then 0 in for y, and solve. So if I put 0 in for x, then I have y equals negative 3 times 0 plus 1. So when I solve, negative 3 times 0 cancels out to 0, y equals 1. Okay, and then the next part I need to solve when I put 0 in for y. So that would be 0 equals negative 3x plus 1. So I need to solve for x. So subtract the 1, subtract the 1. Negative 1 equals negative 3x. Divide by -3. So x equals 1/3. So when I'm graphing this, I have the point 0, 1, so that would be right there, and I have the point 1/3, 0. So 1/3, 0 would be about right there. So that's going to be my line. Doesn't have to be exact, but if you show me that you've done a couple points, then it'll be close enough. Okay, we recognize this line, then we use our 2 points where x is 0 and y is 0. In some cases, it is not going to be a line. Right here we have a square. Okay, so it's x squared something, so that makes it nonlinear. You may not know which one it is exactly if you discover it's nonlinear, but you will know it's nonlinear because there's a square on it. So in this case, we're going to have to do a few more points. We can't just pick, the basic points. We have to pick a few more. So on these, I'm going to pick -2, -1, 0, 1, 2, and you can pick more if you want, but 4 or 5 points are probably enough to see a trend. Okay, so the first point we put in, we have y equals -2 squared minus 2 times -2 plus 4. And if we type that into the calculator, we get y equals 12. So I put 12 in right there. Then I can graph that point. Okay, now the next one, we just replace the -2 with a -1. So I'm going to take this and make it a -1. A -1. Alright, and when we put in a -1, we get 7. Alright, so I'm going to put a 7 there, and then I can put in a 0, and when I put in 0, I get y equals 4. So I just type this into the calculator, and when I put in 1, a positive 1, I type that into the calculator, and I would get a 3. And finally, if we type in a positive 2 into the calculator, the last number in my chart, then I get a positive 4. So now when I just graph these points individually, my first point is -2, 12, so -2 on the x, and then all the way up to 12, which is 9, 10, 11, 12. It's way up here. So that's the first point. The second point is -1, positive 7. So I come up to the 7, so it's right here. And then I have 0, 4, and the next point, 1, 3. And finally, the last point is 2, 4, 2, 4. So I should be able to kind of see what is happening to this graph. It's starting way up here high, and then it's coming down, and it's going to turn around right here, and then it's going to turn back up. So I can kind of see that it's going to continue on and go up like this. And that's how we get a quadratic formula, which we discussed before. Okay, so again, in this next one, we should notice right off this is not linear. And that is because there's a square root in it, so it can't be a linear function. So we're going to do the same thing we did before, where we set it up as y equals 2 times the square root of our x that we're going to change, so we're going to put in different x values, plus 2 minus 3. So we just substitute in different values for x to find our new y. Okay, so if we want to use the values -2, -1, 0, 1, 2, that's just to kind of get a baseline. That's not always going to work. Sometimes the values won't work for us, but we can try and see what happens. So if I put in a -2, and then I type it in the calculator and do the work, then I get a -3 out. So that one works. I get a -3. So if I graph that, -2, -3 is going to be about that point right there. So that would be my first point. And my next point, I can put in a -1. So if I put in a -1, then I get a -1 out. So -1, -1 would be about right there. Alright, the next point, if I put in 0, if I put 0 in, I get a kind of weird number out. I'm going to get a -0.1715, and it keeps on going. So we can just round that off, 0.172. So -0.17 is going to be like right there, not very far. So that's at 0. And then if I put in 1, so if I put 1 in right here, and I type that into the calculator, and get another decimal answer of 0.4641, and it continues on. So I'm going to round that off to 0.464, just so I can get an idea of where that would be. So at 1, I'm at 0.46, which is about there, somewhere in there. Not perfect, but close enough. And finally, if we put in the last number that we have, put in 2, a positive 2, and we put that into the calculator, then we get 1. So I would graph 2, 1. So I can kind of see what seems to be happening. It's starting here, and then it's going to rise and then go like that. So that would be your graph. This is actually what we call a square root function, a square root graph, or a parabola, half of a parabola, but this is what your graph would look like. So all you have to do is graph enough points for you to start seeing the trend. So if it's not linear, you have to graph more than 2 points. But if it's linear, you only have to graph 2 points. So keep that in mind. First, you have to identify the graph. So those are your notes over graphing functions by hand. Make sure you can graph linear and nonlinear functions. So go through some practice problems, and then you should be ready for your quiz over this material.